Unite beyond boundaries. Innovate together. Joe's PANKRATION 2024. No border.
Hello everyone, my name is Michal Salanci, and today I will show you the real case study how we went serverless on our project. I am from a small country of Slovakia in Central Europe, over here. I am AWS community builder and the user group leader of user group Košice in Slovakia. Currently, I work as a senior DevOps engineer in a company called T-Systems. Few more words about the agenda. So our project is built on a forward proxy in AWS. So first I will explain what is forward proxy, what types of proxy we have, and then I will compare the old version, which I called server-based proxy, against the serverless proxy. So that's how we went serverless in 2022. So let's get started. It all started with demand for safely reaching the internet from our customers' VPC. Our customer had several VPCs. In fact, it was 16. In every VPC, there was EC2 running either the application or the database in a private subnet. And first, each VPC required an internet access. So yes, this could be achieved very easy by adding the NAT gateway and internet gateway into each VPC. But this was the not best way to do it because you have to deploy as many NAT gateways and internet gateways as you have VPCs. Same would be for any security resource, either firewall, containers, whatever. So we decided to move NAT gateway and internet gateway in a single VPC called the outbound VPC. And everything then was connected with the transit gateway. And this is, by the way, one of the best practices, standards that AWS offers how you should do that. Within a single outbound VPC, there's only one NAT gateway and one internet gateway, and it's more cost efficient than having it in each VPC separately. Later, we introduced additional VPC called Service VPC. So this is where we did the log gathering analytics using Athena, canary synthetics, some kinds of monitoring, and all other stuff that is not important for tonight's presentation. Of course, it was also interconnected through transit gateway as well. So this service VPC was in the middle between customer VPC and the outbound VPC. But this is not how we did it in the beginning. So for that, we have to go back to 2019. Before we actually jump to 2019, let me explain what is a forward proxy from very high level perspective in case you don't understand, because this is very important for the next slides. So just imagine the corporate devices trying to reach the internet, and we can put a middleman device that sits between the client and the internet, and it will intercept the client request, and based on the predefined set of rules, it will block it or allow it. So when clients issue a request, it goes through forward proxy, and if it is allowed to go to the destination, and destination can respond. If the connection is denied, then it is denied, and no connection goes to the destination server. So that's how can we protect ourselves from a bad bots, bad sites, or some kind of adult sites, gaming sites, etc. There is a difference how proxy handles the traffic, and this is also very important. So we distinguish between explicit proxy and transparent proxy, and each of them have its meaning and it's important. So one of the main differences is the TCP termination. When we say something terminates the TCP session, it means it does not forward the TCP between the client and the server as it comes. But when the packet from the client arrives to the proxy, it will establish a new session between itself and the server. So then we have two TCP sessions, one between client and the proxy, and the other one between proxy and the server. This type of behavior is provided by explicit proxy. So the TCP session is terminated on a TCP level, and a new TCP session is established between proxy and destination site. For that case, the destination site does not see who is the client. For the server, the originating client IP is the proxy IP. So that's how proxy can hide the original client IP. On the other hand, transparent proxy does not terminate it, does not terminate the TCP. So it is just forwarding every single packet further immediately after it receives it. Another main difference is how the proxy listens the traffic. So explicit proxy actually listens the traffic on specific IP address or URL with port. That means the client has to explicitly add the proxy address in the request. Transparent proxy does not listen to the traffic on any specific port or URL, so the client can reach it by default and does not need to do anything. Because explicit proxy listens to the traffic on specific URL and port, client has to explicitly configure it on their side. The proxy must be the proxy URL must be part of the code when the client or application wants to use the explicit proxy. With transparent proxy, it doesn't matter, because if he does curl to, like here, Amazon.com, if it doesn't specify anything, it goes to transparent proxy by default. With explicit proxy, client has to specify the proxy address in the request. This brings us to the great security advantage of transparent proxy, because explicit proxy has to be explicitly specified. It can be bypassed. If client does not specify the proxy is bypassed and the traffic does not go through the proxy. With transparent proxy, it can be bypassed because it's getting there by default. Okay, this is enough for the boring theory. Now let's see the real case, what happened to us. So again, we are back in 2019, and this is how we built it in the first place. We developed an EC2 instance with Squid proxy, which is a third-party tool, and we put it in the public subnet. Same instance served both as transparent proxy and explicit proxy. For the filtering, we used concept of whitelist and blacklist, and all the files, whitelist and blacklist files, were stored in S3 bucket. There was also a file called squidconf. That was the configuration file for the squid itself, like the brain of the squid. On this two instance, there was a bash script checking those files every 2 minutes, and if any difference it was detected, a particular file was downloaded and processed by the squid running on EC2 instance. Elastic IP was attached to the instance to ensure it has the same IP no matter what. Default route from the transit gateway was pointing to that elastic IP, and that ensured that all requests for the transparent proxy ended up on EC2 instance. To save the costs, NAT gateway was removed, and same EC2 instance served as NAT instance. Okay, that worked well for some time, but because of the single point of routing, we weren't able to scale it horizontally. We had to scale it vertically, which was very expensive. And as the network started to increase, the network card on EC2 or on the host was not able to serve that many packets. So when we were scaling it vertically, we had to use very large instances, network optimized instances to be precise, and it was very, very expensive. So we decided to refactor it, and this time we wanted to go fully serverless. So now back in 2022, we were thinking how to refactor, and the requirements stayed more or less the same. So, except for the serverless, we wanted to work as whitelist only. meaning everything being blocked by default, and only requests to whitelist URL and IPs should be allowed to reach the internet gateway. Also allowed and blocked requests must be visible in the CloudWatch. So let's see which options did we have when we were building it. At first, you have to ask yourself two questions. Do I want to run it forward proxy on EC2, or do I want a serverless solution? Do I want to rely on AWS native resources or third-party solution? So running EC2, you can deploy plenty of third-party solutions which are capable of doing both transparent and explicit proxy functionalities, such as Squid proxy, Nginx, HA proxy, and many, many more. All this can be also running on EC2 as a container task. For serverless option, you can run EC2 task in Fargate, which is AWS serverless solution for ECS. That means to run ECS task or containers without deploying an EC2 instance, that AWS will deploy it and run it for you. If containers are not your cup of tea, you can also use third-party appliance and purchase it at a marketplace and use them in conjunction with gateway load balancer. That's like Big IP LTM or NAPM, Palo Alto Network Firewall, Cisco Firepower, Fortinet, FortiGate, and some others. With that setup, the traffic flows to gateway load balancer when it continues to the appliance itself for inspection, and if it is allowed, the request is sent back to gateway load balancer and towards the internet gateway. All those appliances can run as explicit, that means terminating the TCP, or transparent proxy. But this is the least preferred setup because it can be more expensive and more difficult to build. So the question was, are there any AWS native options and possibly serverless options we can use? There is AWS Network Firewall. It is managed firewall capable of L3, L4, and L7 packet inspection, and it supports multiple types of rules. Stateful, stateless, domain name, suricata compatible. It resides in VPC and creates the endpoint to the particular subnet. However, the network firewall is not capable of explicit proxy, so we can use it only for transparent proxy. It can terminate the TCP, nor it can't listen the traffic on specific address and port. So taking all the options under consideration, for transparent proxy, we were looking for cost efficiency solution with least operational overhead possible, and ideally to be AWS managed. For that, gateway load balancer with security appliances is expensive option. This is out. Sticking to AWS native solution, third-party proxies running on EC2 and Fargate were not option as well. So for transparent proxy, we decided to go with AWS Network Firewall. For explicit proxy, the situation was different. We can't go with AWS native solution, as Network Firewall does not support explicit proxy. From cost perspective, gateway load balancer was out of the game. And transparent proxy runs on AWS managed resources. We want to explicitly run on managed resources as well. Or other words, we did not want to deal with any infrastructure. So all EC2 options were out of the game. That concludes third-party proxies running in container and managed by Fargate as the only option. Because our team has a previous experience with Squid proxy running on EC2, we decided to stick to that. So for explicit proxy, our choice was Squid proxy running in container managed by Fargate. So final decision looks like this. For explicit proxy, Squid with Fluent bit in ECS task managed by Fargate. In the same Fargate task, we introduce Fluent bit log processor as a sidecar container, which processes the logs created by the squids and sends it to CloudWatch. For transparent proxy, the network firewall. Putting it all together, this is how it looks like as a whole architecture. NAT gateway was introduced back, so nothing is being done on dedicated resources. Lastly, the network load balancer was introduced to listen to the traffic designed for explicit proxy and sends it to its targets, which is Fargate tasks. So there is a final question. Is this a true serverless? Some people say no, as long as there is no API gateway, tons of Lambda code, S3, etc. It's not a serverless. But I say it is because there is no server infra or any infrastructure for me to burden. Everything is either AWS managed or serverless, like network load balancer, Fargate, network firewall, NAT gateway. Everything is out of the game for me as for the infrastructure. And that looks pretty serverless to me. And that concludes my presentation, and thank you for watching.